Welcome to this explainer. Okay, today we are going to completely reframe how you think about IT and security updates. We're tracking the journey of a secure change. Now, I know what you're thinking. Usually change management just feels like a massive bureaucratic hurdle, right? Just endless paperwork, approvals, and red tape that totally bogs down innovation. But today, we are going to flip that perception on its head. We're going to see how this process, when it's actually done correctly, is your ultimate shield against cyber vulnerabilities and unplanned outages. So let's dive right in.
Here is our game plan for today. We'll start with the blueprint of secure change, move right into vetting the impact, and then hit the danger zone of executing the change. After that, we'll navigate the technical implications and wrap it all up with documenting the journey.
All right, kicking things off with Section 1, the blueprint of secure change, laying the foundation.
So before we even think about touching a single piece of code or messing with any hardware, we need a highly structured blueprint. This is how we manage risk and minimize those dreaded unplanned outages. Let's break down these specific business processes that directly impact our security posture. First up, we've got approval mechanisms. Look, if your approval process is weak, poorly vetted changes are just going to slip right through, and you will inadvertently introduce brand new vulnerabilities into your system. Next, ownership protocols. Every single asset on your network, whether it's a massive database or just some quirky legacy application, needs a designated custodian. Ownership creates accountability, right? It ensures someone is actually on the hook for reviewing that asset's security. And finally, stakeholder interactions. This isn't just an IT thing. We're talking management, customers, investors. Basically anyone who'd have a really bad day if a breach happened. By pulling in diverse internal and external stakeholders, we get a much wider, clearer view of potential threats.
Moving right along to Section 2, vetting the impact, or the trials of the change.
Okay, so the blueprint is laid out, but every proposed change has to be rigorously vetted and tested before execution is even on the table. This is where impact analysis steps in. Think of tools like a business impact analysis, or BIA. We aren't just crossing our fingers and guessing what might happen to the network. We're systematically and proactively hunting down possible security risks before they even have a chance to happen. For security analysts, this step is absolutely crucial. It tells us exactly how we need to allocate our resources to pull off the change safely. Where our staff needs to focus, the budget we'll need, and the specific tools required to keep everything locked down tight.
Once we run those tests, we get our results back, basically the report card for our cybersecurity measures. But keep in mind, not all test results are created equal. On one hand, you have vulnerability scanners. These give you highly detailed technical insights specific to each system, and the best part, they completely lack bias. It's just raw, unvarnished data. But on the other hand, we have human risk assessments. These are, by nature, a bit more subjective, and they definitely require additional context to fully understand. Both are incredibly valuable, but you really have to know exactly what kind of test result you're looking at so you can effectively adjust your defenses and understand your true risk profile.
All right, step 3. Executing the change. We are officially navigating the danger zone.
So if the change is vetted, we understand the impact, it's approved, and now we hit the most critical, and honestly, the riskiest phase of the whole process, execution. So what happens if execution just goes completely off the rails? Well, that is precisely why every change needs a formal backout plan. And no, this isn't just mashing an undo button. It is a meticulously outlined, predefined action list that you have to write up long before any installation even starts. If post-implementation testing shows the new system is totally failing, this plan is your safety net. You just follow the steps, uninstall the new system, reverse the process changes, and get everything back safely to its pre-change working state. It guarantees that your automated business operations can just keep humming along smoothly, even if the new deployment crashes and burns.
Now, a quick question. When exactly should we execute these risky changes? Well, there's a very famous old saying in the IT world, maintenance on a Friday is guaranteed work on a Saturday. I mean, it's funny, but it's an insider joke grounded in absolute truth. You have to choose your maintenance windows so carefully. A maintenance window is just a designated time frame picked specifically to keep business disruptions to a bare minimum. For example, if your engineers are hammering the corporate VPN all day, but traffic drops off a cliff after 6 p.m., well, you plan that maintenance window for 7 p.m. It's all about balancing those business impacts and always planning for the unexpected.
Which brings us to Section 4, navigating technical implications, taking a look at those real-world consequences.
Executing a change causes actual ripple effects across your cybersecurity landscape. We're talking altering network infrastructure, needing more server capacity, or tweaking security protocols. A fantastic example of this is how we handle input validation. So we have allow lists, sometimes called whitelists. These specify only the approved inputs a system is allowed to accept. It is incredibly easy and just super safe because you define exactly what is permitted, like say only expecting a postal code format, and the system just flat out rejects everything else. Contrast that with block lists or deny lists. This is where you try to ban specific malicious inputs, like the sneaky apostrophes and semicolons attackers use for SQL injections. The huge problem here? A developer literally cannot anticipate every possible crazy input or attack vector. Block lists are a total maintenance nightmare. They break upper layer programming constantly, and honestly, they're pretty easy for a clever attacker to bypass. Allow lists are just vastly superior for keeping things locked down.
Another massive technical implication of a change is downtime. In IT, we are obsessively chasing the absolute gold standard of availability, which is 99.999%. We call this 5 nines availability. Avoiding unplanned downtime is absolutely critical, especially when you've got strict service level agreements or SLAs that you legally have to meet with your clients.
But let's put that into perspective for a second with the number 3.65. If a system promises what sounds like a pretty good metric, say 99% availability or 2 nines, that actually means they're allowing for up to 1% downtime over a year. You guys, that equates to 3.65 days of complete offline unavailability. That's a stark reality for a business. 3.5 solid days offline? That means plummeting productivity and potentially massive data loss. And that is exactly why we have to be so careful scheduling and managing our planned downtime for maintenance.
Often, during that scheduled maintenance downtime, you're going to need to perform a service restart. This just means halting and then immediately reactivating a system's service so your updates, patches, or config changes can actually take effect. It's literally like turning off a car that's acting a little glitchy and simply restarting it to clear the issue. But, and this is a big but, you cannot just restart services blindly. You absolutely must ensure potential users are notified about the downtime, and you have to meticulously map out what other systems are plugged into that service so you don't accidentally knock an entire critical database offline.
And mapping out those connections means you need to understand your dependencies. Dependencies are basically software relationships, where one component or service completely relies on another to even function. Imagine a really heavy roof supported by large stone columns. If you just yank out one of those columns to do some maintenance without understanding its load-bearing role, you jeopardize the entire structural integrity of the entire building. It's the exact same concept in IT. This is especially true with those older legacy applications that might, stubbornly require some completely outdated operating system just to run. If you don't map out those software relationships before making a change, pulling out one digital beam could cause a catastrophic system collapse.
And finally, Section 5. Documenting the journey. Achieving immortality.
So, your system change might be running perfectly, but listen to me, it is not fully secure until it reaches immortality through rigorous documentation. First, that means updating your diagrams. Diagrams are the literal visual maps and blueprints of your network. Whenever a change happens, update them and strictly put a version control number on every single one. Next, updating policies. These are the directive rules that govern how your IT systems are actually used and secured. And finally, updating procedures. These are the nitty-gritty, step-by-step instructions needed to implement those rules. Actually, this is especially vital so your users know exactly how to handle those quirky legacy apps we were just talking about. If you skip updating these blueprints and controls, undocumented changes just pile up. And that directly leads to poor performance, severe non-compliance, and crippling instability when you're trying to respond to a fast-moving security incident.
Central to keeping all this documentation and code straight is version control. This is a system, think tools like GitLab or GitHub, that records changes to files over time. It lets you track modifications, pinpoint exactly who made them, and seamlessly patch security vulnerabilities. The stakes here are just unbelievably high. I mean, imagine the absolute chaos during an active cyber attack when a team member yells out, "Wait, are we on version 2.3?" only to find out the system was quietly updated to 4.0 3 weeks ago? Without proper version control, trying to correlate, triage, and patch vulnerabilities across a whole organization is basically impossible. It is an absolute necessity.
Which brings us to our final provocative thought for this explainer. I want you to look at your own environment and ask yourself honestly, if an unauthorized change happened today, right now, does your documentation reveal the truth or does it hide the vulnerability? Excellent change management is about so much more than just pushing new software features out the door. It is about maintaining absolute visibility, security, and control over your entire IT landscape. So challenge yourself to evaluate your systems and the integrity of your own documentation based on what we've covered today. Thank you so much for joining me on this journey of a secure change. Keep learning, keep organizing, and stay secure out there.